Now we are going to discuss about the tractive properties of tires. There are three influencing agents that decide the tire tractive characteristics. That is what we are going to discuss about. That influencing agents are first one pressure, second slip, and third one friction. Now you understand, I hope you understand that how the slip occurs. Actually, the tire the tire stick with ground surface, that is your contact surface, come close enough contact with the road surface and it gonna break. So first thing adhesive, break and slip. These three process takes place. These three process decides the tractive properties of tires. Tractive properties. Okay. Let us see one by one. Okay. Before getting into this picture, we must understand the basic concepts of tire, right? Okay. Let us take cycle tire and how the cycle tire gonna behave. Okay. Let me try a cycle tire here. Okay. Let us consider this is a cycle tire which is going to placed on the ground surface, right? It is going to have 8 spokes. Let us consider like this, right? Okay. If you draw a simply free body diagram of the cycle tire which is going to placed on the ground surface, it will be like this, because the ground surface is going to generate the reactional force against the vertical weight of the cycle. The total cycle weight acts at the center point, that is the actual point of the tire or wheel, right? It is going to be like this, right? Okay, fine. You know very well that the spokes of cycle tire are very thin, that you know very well, right? Okay. If it is subject to compressive load, what is that it gonna take? Yes, it is going to buckle. So the spokes are assembled with tension, not like compressive load, right? Okay. Let us take the wheel away from the ground surface. Okay, wait. Let us take the cycle tire away from the ground surface. Only two spokes are considered here, which is 1 and 2, right? Fine. So it has only two loads. Sorry, only one load, that is tensile load acts at the spokes like this. Upward force at spoke 1 and downward force at spoke 2. Right? These two forces will equilibrate each other, right? Okay, fine. If we place a tire cycle tire on the ground surface, what will happen? The ground surface will generate the reaction force at the bottom of the tire, right? Wait, I repeat again. If we take the cycle tire away from the road surface, there's only tensile force will be act at the spokes. These inbuilt forces will equalize each other. Okay, fine. After that, if you place a cycle tire on the road surface will create a reaction force from the ground. So what will happen here? So if the ground surface generate the reaction force against the vehicle weight, the tensile load at the spoke number 2 will be reduced, and it marks here as small arrow because of reduction. Okay, then note this point. This force is not reduced. This force, the downward force, will be reduced. What will happen? So, if we consider this is a 10 Newton, if it is 6 Newton, what will happen? This force, this force will pull these spokes. This force will pull this spoke in upward direction. What happens here? Here we can understand that upward force is responsible for the support of the wheel. In other words, it gonna hang from the top. I repeat, it is gonna hang from the top, that is not push from the bottom, right? If you didn't understand here, okay, let us take the force value maybe 10 Newton, right? The force may be 10 Newton. Okay, so after contact with the ground surface, the force value will be get reduced to 8 Newton. Okay, fine. So totally we have 8 spokes. The second spoke has, so we consider the force act at the spokes maybe 10 Newton. Just consider like this. So after reduction at the spokes 2, the force may be equal to 8 Newton. So we have 8 spokes, 1, 3, 8 upward spokes, 5, 2, 6 downward spokes. Fifth spoke, the force may be 10 Newton. Sixth spoke, force 10 Newton. Second spoke 8 Newton. Total force 28 Newton. In upward direction 10, 10, 10 at 1, 3, 8 spokes. So totally 30 Newton. So compared with the downward spokes, upward spoke force is greater than downward, right? Okay. So what will happen? These forces will pull the downward direction spokes towards upward. So these forces are the main responsible for support of the vehicle, right? Okay, fine. Here we can understand that upward force is responsible for the support of the wheel. In other words, it gonna hang from the top, that is not pushed from the bottom. I repeat, it is gonna hang from the top, that is not pushed from the bottom. Okay, so it is exactly happens at the vehicle force, right? It is exactly happens at the vehicle tire, and which holds from the top. Instead of spokes, the tire side wall gonna hang the tire, right? Okay, let us discuss. Okay, let me draw a cut section of vehicle tire. Please wait. These are the side walls, beading point. These are the wheel alloy. The bottom part. Okay, so this is upper part and lower part. This is the alloy rim. Okay, this is the rim. Okay, so here what happens actually? In cycle tire, spokes get tension because of arrangement, and that is inbuilt. In vehicle tire, side wall is going to get this tension because of pneumatic, that is the inflation pressure. So that air pressure is what gives the tension in vehicle tire. So let's see what happens at this situation. Okay, right. Wait. Yeah, of course. You can say that the inflation pressure, that is what gives the tension, but keep it in mind that is for cushioning effect, not exactly for tension given by the air pressure, right? So the tension given by side wall of the vehicle tire, right? Keep it in mind. Okay. So now consider the inflation pressure going to be like this. Consider that the tire inflation pressure going to be like this. So the top of the pressure of the sidewall will pull the tire in upward direction. How? From cycle tire you can understand that the upward spokes will pull the tire from the top, right? Okay. So here by using the cycle tire you can say that the upward force is higher than the downward direction forces. So what happens actually? Okay, let me clear this. Take a tire like this. What happens with pressure? So in upward direction the pressure may be like this. when it contact with ground surface, the downward direction force will be reduced, right? So compared to upward direction forces, the downward direction forces are very less, right? So what happens now? The upward direction forces will pull the tire from the ground to the top, so it will be hang from the top, right?